Hello student, welcome to Chem Gyan. Today we are having lecture number 13. Chapter is solutions, and the topic today we are going to study is azeotropic mixture, or it is also called as azeotropes, or it can also be called as azeotropic solution, right? But before we move on this part, what is azeotropic mixture, we have to understand certain things, right? What is that? Let's understand. First of all, we have to understand is what is a boiling point, what is a binary solution, right? We have to understand that part also. Okay, we'll go in sequence. First of all, let's understand what is azeotropic, right? In a very small way, right? Azeotropic mixture or azeotropic solution is those solution which have constant boiling point. Azeotropic mixture are that mixture which have constant boiling point, right? Now student, what is boiling point? How we define boiling point? If we want to understand the exact definition is the temperature at which the vapor pressure of a liquid become equal to atmospheric pressure, right? But for time being, we'll keep it aside and we understand some other part. Okay, now tell me, what is boiling point of water, student? We all know that boiling point of water is 100 degrees Celsius. If I write this in Kelvin, it is 373 Kelvin, correct? Okay. Now, one more thing. What is boiling point of ethyl alcohol, C2H5OH? Actually, it's something 78.5 approx, right? But for make it simplicity, I'm writing here 80 degrees Celsius, right? Now if I write this in Kelvin, it is approximately it is 353 Kelvin, right? Clear? Very precisely, if I say boiling point of water is 373.15 Kelvin. Okay, now approximately I take it as 80. Okay, now student, if I take a pure water, right, it will boil at 100 degrees Celsius. If I take a pure alcohol, it will boil at 80 degrees Celsius, right? Okay. Now, what will happen if I take mixture of, suppose this is alcohol, I write A, and water, I write W, right? So I have alcohol and water. If I take this mixture, right? Now, if I want to boil this, right, what is the boiling point? Will be 80 or 100, or it will be different from this? Actually student, it will be something different of that. Okay, but my question is not what is the boiling point of that. My question to you is, if I mix this alcohol and water, right, and if I ask you to separate this, I mix this because both are liquid. I mix both liquid, right? Now I want to separate this. Can I separate this? Right? Is there any procedure you know to separate? Yes, we know one procedure, and that procedure is called what? It is called distillation. It is called distillation, right? Distillation can be simple distillation or it can be fractional distillation. Now, when to use simple distillation, when to use fractional distillation? See, when the boiling point between two liquid is 30 or greater than 30, then we use simple distillation. But when the boiling point is less than 30, we use what? We used fractional distillation. Now see, there's not much difference. दोनों में फर्क ज़्यादा कुछ नहीं है, ठीक है. सिर्फ फ्रैक्शनल डिस्टिलेशन में हम फ्रैक्शनेटिंग कॉलम यूज करते हैं, ठीक है. आई एम नॉट ड्राइंग फ्रैक्शनेटिंग कॉलम वो ईयर, बट आई एम एक्सप्लेनिंग इट, ठीक है. अब सपोज मैंने अल्कोहल और वाटर का मिक्सचर ले लिया, राइट. तो यहाँ वेपर्स भी फॉर्म होगा, ओके स्टूडेंट. एंड दीज वेपर्स विल बी फॉर्म, ऑब्वियसली अब अल्कोहल भी होगा, वाटर भी होगा, ठीक है. बट सपोज ये वेपर्स भी बन गए इनके. नाउ व्हाट आई डू इज, मैं यहाँ से एक ओपनिंग करता हूँ एंड दिस आई कनेक्ट टू अ वेसल, राइट. सपोज आई कनेक्ट दिस टू अ वेसल, राइट. और यहाँ मैं I attached what? If I want to distill this, what I have to attach? Tell me. It's a condenser, right? So condenser होगा, vapors यहाँ से जाएंगे, condenser लगा हुआ है. condenser का काम क्या है? It will condense that vapor into a liquid state, right? And this liquid will get collected over here. Okay, student. Now, my question to you is this. If I want to do this process, right, again, it was not visible, I think, again I'm repeating it. I have taken alcohol and water mixture. Suppose I heat this, right, I heat this. When I heat this, vapors will be formed, right. मैंने यहाँ condenser लगाया, वो condense होगा and liquid will, I get a liquid here, right. Now question is, I want to separate this water and alcohol. So what I'm going to do is, I am fractional distillation. And fractional distillation, what will happen? As the temperature comes 80 degrees Celsius. See, पहले तो यहाँ temperature 35-40 degrees Celsius कुछ होगा और room temperature होगा. When I start heating this, तो इसके vapors बनेंगे. Obviously water के भी बनेंगे, alcohol के, but alcohol के vapors ज़्यादा होंगे, right? So 80 degrees Celsius, mostly all the alcohol will come over here, vapors. And when I condense that, I will get what? I will get alcohol, right? Obviously, some amount of water will be also there. When I redistillate it, by doing the process, ultimately, I can separate alcohol and water, right? मैं इन दोनों को separate कर सकता हूँ. Okay. Now, student, right? Suppose all the alcohol is removed. Now, the temperature will start rising again. See, one thing very important. जब तक पूरा अल्कोहल इस वेसल से निकल नहीं जाता, टेम्परेचर 80 ही रहेगा, ठीक है. और जैसे ही सारे अल्कोहल निकल गए, टेम्परेचर विल स्टार्ट राइजिंग. व्हेन द टेम्परेचर कम्स एट 100 डिग्री सेल्सियस, अगेन टुक अनदर वेसल, कलेक्ट वाटर इन दैट, राइट. क्लियर? दिस इज हाउ आई कैन सेपरेट अल्कोहल एंड वाटर बाय फ्रैक्शनल डिस्टिलेशन. बाय व्हाट? Fractional distillation. I hope this is clear, right, student? Now, but in azeotropic mixture, if the mixture is what? Azeotropic mixture. Now understand, student. If the azeotropic mixture is there, I can't separate this the way I separate it over here. ठीक है. अच्छा, very important, student. How this can be separated? यहाँ से separate कब होगा और कब नहीं होगा? This is what we have to understand. Let's first understand this part over here. When we can separate two liquids by using fractional distillation, right? See, I have alcohol. So there will some mole fraction of alcohol in this liquid, right? In a given liquid, there will be some mole fraction. And obviously there will be some mole fraction of water. When I write like this XA, it is a mole fraction of A in liquid state. XW is mole fraction of water, right? Again in liquid state. Okay. But when they convert into vapor state, right? So in this also alcohol and water will be present. See, vapors may be present होगा, liquid में तो है, but vapors में भी दोनों present होंगे. So mole fraction of alcohol in vapor state I write as YA, right? and mole fraction of water in vapor state, I write WA. Right? Understand, student, when fractional distillation can take place, when it can take place, it can take place only when the fraction of alcohol and water are not equal. Understand, student, not equal. जब इनके मोल फ्रैक्शन अल्कोहल और वाटर लिक्विड स्टेट और वेपर स्टेट में डिफरेंट होगा, तभी हम ये फ्रैक्शनल डिस्टिलेशन वाला प्रोसेस अप्लाई होगा, अदरवाइज नहीं होगा. एज़ोट्रॉपिक मिक्सचर में क्या होता है, जिस फ्रैक्शन में अल्कोहल वाटर यहाँ प्रेजेंट है, सेम फ्रैक्शन में वो वेपर्स में भी प्रेजेंट होते हैं ना. ये बात थोड़ा समझते हैं, ट्राई टू अंडरस्टैंड. सपोज आई से I have 100 molecule. For simplicity, I'm saying I have 100 molecule of alcohol, and let's say I have 400 molecule of. I'm talking in terms of molecule. Actually, I should talk in terms of moles, but simplicity to make you understand. Yeah, 400 molecules मेरे पास water के, right? So they are in the ratio of 1:4, right? Okay, and they will obviously have some mole fraction. Suppose same ratio यहाँ भी आ जाए. वाटर का वेपर्स बन रहा है, राइट, अल्कोहल का भी वेपर्स बन रहा है, और वो उसी रेशियो में यहाँ भी प्रेजेंट है, 1:4 के रेशियो में, राइट. मैं कंडेंसर से इस वेपर को कंडेंस करूंगा, तो सारे वेपर्स विल कन्वर्ट इनटू लिक्विड. व्हेन ऑल द वेपर्स विल कन्वर्ट इनटू द लिक्विड, दिस लिक्विड विल आल्सो हैव द सेम मोल फ्रैक्शन व्हाट वाज प्रेजेंट हियर. वेपर्स में जो मोल फ्रैक्शन होगा वही तो लिक्विड में आएगा, और यहाँ जो मोल फ्रैक्शन होगा यहाँ भी है, तो दे कैन नॉट बी सेपरेटेड. अंडरस्टैंड, बिकॉज सेम फ्रैक्शन यहाँ था, सेम फ्रैक्शन यहाँ है, तो हमने सेपरेट नहीं कर पाएंगे. फिर से इसका फिर से डिस्टिलेशन करोगे, अगेन दिस इज गोइंग टू बी सेम वे, राइट. सो इफ द मोल फ्रैक्शन ऑफ XA and YA is same, then we cannot separate them, and if we can't separate them, then that mixture will become azeotropic mixture. Understood, student? Right? For time being, we are studying about fractional distillation. Fractional distillation में mole fraction vapor phase में और liquid phase में are not same. Understand this, right? Clear? Now, we'll understand what is azeotropic mixture or azeotropic solution. Okay. Now, azeotropic mixture. See, there need for a solution to be azeotropic, कुछ conditions हैं. उसमें condition number 1, the solution should be binary. Means it should consist of one solvent on only one solute. Right? It should be a binary. Okay. Second very important point, student. Very important point. The point is, they must be present in a fixed composition. Fixed composition. What is this fixed composition? See, इसके पहले यहाँ जो मैंने एग्जाम्पल लिया वाटर और अल्कोहल का, तो I can take in any proportion, right? Water, suppose I say I take 80 ml, alcohol I take 20 ml, or 40-60 or 50-50, any proportion I can take. ठीक है, चलेगा. Okay, and I can do fractional distillation. But for an azeotropic mixture, so that the liquid have constant boiling point, for that there is a need for that is there should be a fixed composition. उनका composition एक fixed होना चाहिए, fixed proportion होना चाहिए, right? Clear? Fixed proportion, fixed ratio. Now, one more point I can add in this. It cannot be separated by fractional distillation. Fractional distillation से हम इसको separate नहीं कर सकते. Okay, right? Now, and the most important point, mole fraction of alcohol C2H5OH and mole fraction of alcohol in liquid state and mole fraction of alcohol C2H5OH in gaseous state or vapor state should be equal. Same way I can write for water, it also should be equal, student. Right? This is the most important condition. This has to be satisfied. Right? Now, This is the condition. Okay. Now student, understand again, they must have constant boiling point. They must have what? Constant boiling point. What is this constant boiling point? I explained you before. Again I'm explaining. Right. When I say constant boiling point, see, water का boiling point 100 है, alcohol का 70 or I say 80 है. Okay. But when I mix them in a certain fixed ratio, what is that fixed ratio? Let's understand. C2H5OH, ethyl alcohol, suppose I take in the 95%, right? Approximately 95%. And water, suppose I take 5%. अगर मैं इस ratio में ले रहा हूँ, ठीक है? Okay. Then the mole fraction of water and alcohol in vapor phase and liquid phase will be same. Got that, student? Okay. Just say here alcohol and water is present in some ratio 1:3. Here also they will present the same ratio. Here also they will present the same ratio. Every time you do the distillation, they will present the same ratio. If they are present in the same ratio, you cannot separate them. Right? So I will say they have constant boiling point. Right? Okay. Got that? Right. Now student, azeotropic mixture is of two types. Let's understand. Azeotropic mixture is of two types. One, which have minimum, or one which is called minimum boiling azeotrope, and other one will be maximum boiling azeotrope. Right, एक minimum boiling azeotrope और एक maximum boiling azeotrope. Right. Now we'll understand with example. First example, I take ethyl alcohol C2H5OH and water. These are binary solution. तो binary solution में दो component, ठीक है? Binary solution मैंने ले लिया. What is the original boiling point? Ethyl alcohol actually 78.5, but for simplicity I'm taking 80 degrees Celsius. Water is 100 degrees Celsius. Right? In Kelvin, if I have to write, this will be 373 Kelvin and this will be 353 Kelvin. For a solution to be showing minimum boiling azeotrope, the composition is 95% will be of ethyl alcohol and only 5% will be water. Right? If I maintain this, then and only then I will get minimum boiling azeotrope. अब minimum boiling azeotrope का मतलब क्या होता है? I will explain you why it is called minimum boiling azeotrope. But for time being, understand that for a solution to be minimum boiling azeotrope, this composition should be there. ठीक है? Now, so if I have this composition, right? Now student, understand the mixture of this solution, ethyl alcohol and water, if mixed in this proportion or in this ratio, the boiling point of this solution, will be what? It will be less than this. मतलब 353 से और 373 दोनों से कम होगा. Right? So the boiling point is 351 Kelvin, student. Because the boiling point is less, then both 353 and 373 दोनों के boiling point से ये boiling point कम है, इसके लिए हम लोग उसको बोलते हैं minimum boiling azeotrope. Got that? Clear? Okay. Now here also we see the other example. For maximum boiling azeotrope, example is at HCl and water. right? Boiling point of HCl is, if I write in Kelvin, because if I write in degree Celsius it will be negative, so I write in Kelvin 188 Kelvin, and the boiling point of water we know 373 Kelvin, right? Composition or percentage, if I talk, okay, this I take in 20% and water I take 80%. This composition has to be maintained for a solution to be isotrope and for a solution to be showing maximum boiling azeotrope. Clear? 20-80%, right? And it will show maximum boiling point. Maximum boiling point means what? The boiling point will be greater than 188 and 373. इन दोनों से boiling point इस mixture का ज़्यादा होगा. कितना होगा? 383 Kelvin, student. Right? The boiling point will be 383 Kelvin. Got that? Okay. Now let's understand by the graph now. That's very important, student. Graph. Okay. I hope you remember this graph. We have studied. Or let's check. I draw it here. Now. Here vapor pressure, here mole fraction, right? If you remember the graph of one thing more, student, it minimum boiling deviation, right? Or I talk to you later after drawing the graph. Okay, the graph is like this. This is expected, right? But understand, this show positive deviation. It show what? Positive deviation from Raoult's law. It shows positive deviation from Raoult. This solution show positive deviation. So when I say positive deviation, the graph will be somewhat like this. Understand, it is showing positive deviation, right? Similarly, here also positive, here also positive, but I'm not drawing that. Only I'm drawing off total, right, student? Now understand, here if I draw like this, okay, suppose I say see 95% is what? 95% is alcohol. Suppose you say 100% alcohol is here, right? Mole fraction of alcohol C2H5OH is 1 here. Matlab it is 100%. Here it is 0%, right? So here 95% of alcohol is there. How many percent? 95% of alcohol, right? And only 5% of water. Understand that. See, अगर यहाँ 95% alcohol है तो obviously 5% क्या होगा? Water होगा, right? इस condition पे only in this proportion, right, I will get maximum vapor pressure, right? See, vapor pressure यहाँ कम है, but ये maximum है. फिर यहाँ से increase हुआ, यहाँ से decrease हो गया, और वो किस पे highest था? इस percentage पे, 95% of alcohol और 5% of water पे. Correct, student? Now, so when, and very important, vapor pressure, right, and boiling point का relation क्या है? Vapor pressure and boiling point are inversely proportional, student. Understand that. Vapor pressure and boiling point are inversely proportional, right? Now, how? Let's understand here this. Okay, I explain here. Let's see. Suppose, according to definition, boiling point of anything, if I have to define, it is like when the temperature or when the vapor pressure of that liquid which I'm talking about, when the vapor pressure of a liquid become equal to 1 atmospheric pressure. And when I say 1 atmospheric pressure, it is 760 mm of Hg, right? Suppose I have any liquid, right? At a normal condition, its vapor pressure is 500 mm of Hg. So if I have to boil that, I have to make the vapor pressure till 760. And to increase the vapor pressure from 500 to 760, I have to heat that. When I heat, vapor pressure will increase, as soon as this liquid got the vapor pressure 760, it will set to be boiled, right? But suppose I have another liquid, right, which has a vapor pressure of 300 mm. Now tell me, which will boil first? Obviously 500 mm will boil first, right? It will require less temperature to boil, right? Here this will require more amount of heat, so to acquire 760 mm of Hg. I hope you're getting that point. ठीक है, देखो ये 500 mm है, इसको अगर मुझे 760 लेके जाना, सपोज मुझे हीट करना पड़ेगा, इसको भी मुझे हीट करना पड़ेगा, राइट? अगर मैं सेम अमाउंट ऑफ हीट दे रहा हूं तो दोनों एक साथ में बॉयल नहीं होंगे, इसको कम हीट की जरूरत है, बिकॉज ऑलरेडी 500, उसको 760 होने के लिए थोड़ा कम हीट की जरूरत है, बट ये 300 है, उसको 760 होने के लिए ज्यादा हीट लगेगा। मतलब जिसका वेपर प्रेशर कम होगा उसका बॉइलिंग पॉइंट ज्यादा होगा, और जिसका वेपर प्रेशर ज्यादा होगा उसकी बॉइलिंग पॉइंट कम होगी। अंडरस्टूड? So that is what I want to explain over here, that vapor pressure and boiling point are inversely proportional. Vapor pressure and boiling point is inversely proportional. Got that, student? Right. Okay. Now understand, यहाँ vapor pressure सबसे ज्यादा है तो obviously इसका boiling point सबसे कम होगा. Got that? यहाँ vapor pressure सबसे ज्यादा, boiling point सबसे कम, and that's why it is called minimum boiling azeotrope. Clear, student? Understood? Right. Now let's see over here. In this case, if I draw the graph, same vapor pressure versus mole fraction. Suppose this is expected, right? This is expected one, but now the graph actually it shows negative deviation. It shows what? Negative deviation from Raoult's law. Negative deviation from Raoult's law. Understand, student? So when I say negative deviation, graph will become something like this. Correct? Right. Now at this point, I use this one. At this point, okay, if I draw like this, right, this is 20% of HCl. So here 20% HCl is present at this point and 80% water is present. When I take this composition, right, I'll get least vapor. And we just understood जिसका vapor pressure कम होगा उसका boiling point क्या होगा? ज़्यादा. That's why it is called maximum boiling azeotrope. Clear, student? Okay, so this will show maximum boiling azeotrope, means in other way I can say जो liquid negative deviation दिखाता है Raoult's law. We have studied ideal solution, non-ideal solution. Non-ideal solution दो type का, one which show negative deviation from Raoult's law, one which show positive deviation from Raoult's law, right? So the one which show negative deviation from Raoult's law is called as maximum boiling azeotrope, right? One which show positive deviation from Raoult's law is called minimum boiling azeotropes. Understood? Clear? So this is all about azeotrope and azeotropic mixture, right, student? Always remember one point: fractional distillation and azeotropic mixture. Azeotropic fractional distillation, suppose water and alcohol, तो water का boiling point अलग है, alcohol का boiling point अलग है, और वो उसी temperature पे boil होंगे. बट अगर मैं उसको फिक्स्ड प्रोपोर्शन पे लूंगा तो एक ही टेम्परेचर पे वो बॉईल होगा, और वो एक टेम्परेचर दोनों से कम भी हो सकता है और दोनों से ज्यादा भी हो सकता है, राइट? अगर वो दोनों से कम हुआ, राइट, तो दैट विल कॉल्ड एज मिनिमम बॉइलिंग एज़ोट्रोप, और अगर वो दोनों से ज्यादा हुआ तो दैट विल कॉल्ड मैक्सिमम बॉइलिंग एज़ोट्रोप, राइट? ओके, सो हियर वी कंप्लीट this part of our topic, azeotropic mixture.